Welcome back to my channel. I'm still Teacher Genevieve. In our last discussion, I told you that the ability of paper towel to absorb water is because of the cellulose fiber that the paper towel is made up of. And this cellulose fiber can help paper towel to absorb water because of hydrogen bonds and also capillary action. And explain to you what hydrogen bond is, or hydrogen bonding. That hydrogen bonding is a dipole attraction between molecules. And the hydrogen bonding or hydrogen bonds are formed because of unequal sharing of electrons within covalent compound. So today I want to explain to you this cellulose. What is it? Cellulose is a complex sugar, a polysaccharide. Complex sugar that is made of, it's a linear chain of hundreds of thousands of linked D-glucose. Glucose is a sugar. You have when about hundreds of thousands of them, when they are linked together, you get this cellulose. And this cellulose is a component of plant cell wall. By nature, you can get this cellulose. You can get it through wood, cotton, and other plant fibers. Look at the structure of, this is the structure of D-glucose. I told you cellulose is made up of hundreds of thousands of linked D-glucose. So look at the structure of glucose. If you look at this glucose, D-glucose, that is the desorotatory glucose, the glucose we get after photosynthesis. You know, when plant manufacture their food, at the end of the day you get glucose, that is a starch. So you get this D-glucose through the process of photosynthesis in plants, or you can get it when animals or fungi, when they break down their glycogen to release energy. So this is the structure of 1D-glucose. This is the linear structure. The functional group that it says OH. Glucose is made up of 6 carbon atoms, 1, 2, 3, 4, 5, 6. And then this glucose, the structure can also be in a cyclic form. This one is exactly the same thing with this. This is the cyclic structure of glucose. So let's now look at the formation of this cellulose. Like I said, this cellulose is made up of hundreds of thousands of units of D-glucose. And I've showed you the structure of glucose, the linear structure and the cyclic structure. So when two glucose, a unit of cellulose is when two glucose molecules, when they combine together. You see the first structure I gave, I labeled the carbon atom. So here now this is a unit of cellulose, two glucose, D-glucose coming together. Look at number 1 carbon atom, number 2, number 3, number 4, number 5, number 6. This is the second one. So what usually happens is that the carbon atom in one glucose unit will combine with that is number 4 carbon atom in another glucose unit. So they will link together, losing a molecule of water. And by the time they lose a molecule of water, they will form a unit of cellulose. Look at one unit of it. So two glucose units that are lost water, they'll come to this is a unit of cellulose. So what will now happen? What is this cellulose? How does it is present in paper towel? What happened? Remember the hydrogen bonding I told you, that the reason why hydrogen bonds are formed because of dipole attraction. That one unit of water will be positively charged, and that is the hydrogen, and the oxygen is negatively charged because there is unequal sharing of electron. If you don't understand that, don't bother. So let's now look at what happened before. If I pour water on the table, this is water, I'm pouring it on the table. And this is paper towel. I'll use it to wipe it. You can see it. Paper towel drying up the water. So this ability to dry up this water, look at what happened. Look at one molecule of cellulose. This cellulose. Look at what happened. If you check here, you see that we have OH. That is hydroxyl group. Oxygen and hydrogen. Oxygen and hydrogen. Oxygen and hydrogen. And I told you that in hydrogen bonding, this sharing of electrons are not equal. So most of the electrons tilt towards oxygen, leaving oxygen to be negatively charged, hydrogen positively charged. So in this cellulose, now let's look at, we have how many oxygen? 1, 2, 3. If you look down here, when the paper water was poured on the table and you use the paper towel to wipe it, that water, the cellulose fiber in paper towel, look at what will happen. Look at the first hydrogen here. The first hydrogen here, OH. That's number 2. Look at it here, OH. So look at the oxygen, look at the hydrogen. With oxygen, we come and attach to that hydrogen. And the oxygen that is negatively charged, another molecule of water with hydrogen will come and attach to it, which means this OH will attract 2 molecules of water. Can you see it? Attract 2 molecules of water. If you come to OH number 3, I think we are using this one, OH number 3, the number 3 carbon atom, look at it here. It has OH. The hydrogen will combine with oxygen in water, and another oxygen will combine with hydrogen, give also 2 molecules of water. The same here. We have number 6, we have OH. Another, that is 2 molecules of water will come and attach. This is OH. Hydrogen being negatively charged, hydrogen being positively charged, we attach the negative part of water. Oxygen that is negatively charged, we attach to the positive part. At the end of the day, find out that this is 2 molecules of water, 2 molecules of water, 2 molecules of water. This is the reason why you can see this paper towel absorbing the water. So the OH in cellulose unit will form hydrogen bonding with water. And by the time that is done, that fiber that will now pick the water molecule from on the table. That's why if I press it, you see the water molecule is dropping. So it is the fiber that the cellulose fiber that are taking this water through hydrogen bonding. That's why I told you that hydrogen bonding is a very important phenomenon in chemistry, you see, and science. So the ability of cellulose units to absorb water is because the OH in the fiber will form hydrogen bonding with water in the environment, thereby picking up the water from the table. This is the water absorbency of paper towel. Thank you. To be continued.